Welcome back to the Punny Math Teacher. I'm already on a comprehension question, so back to expectations. There we go. Use twice the video's length to take notes. Wonder their notes to your future self, so make sure you can read them so your handwriting's nice and neat, but it's organized and you know what exactly you said and learned the first time you actually went through these notes with me today. And then our objective today is to describe slopes of linear functions and interpret them in context. And here's our comprehension questions again, so we will be good to go at the end, and off we go. All right, so we have a whole new unit. We're working on a whole new unit. Now, if, get this to focus a little better maybe? I don't know. So if you are in my live classroom and we're working with this together, I would break this into two sections. So after two variable linear inequalities, there'd be a huge review section just to make sure this whole first half of the unit stuck into your head. And then we'd move on with point slope beyond that. This scatter plots is going to be a PDF, so it will not be in our notes. It would be printed off. I'm going to write on the computer, or at least talk it through for that one. So there is a video, it just won't be in actually our notebook. So just an FYI, parallel, perpendicular are two different pages, so we will be coming back to that. Today is slope rate of change, so it's page 26. So, 26. We're going to start with drawing a fun picture of, guess what? Slopes. Woo! All right. And then we're also going to put a little dude on our slopes. And off of our slopes. I'm going to use a pen for their caption bubbles just to make sure it actually fits in the space. So this guy is thinking, this is fun. It's his little speech bubble. And then the second dude is thinking, I don't like skiing. And we're using skiing because it is a slope. Get it? Slope. Ski slopes. This guy is just sleepy and bored, and this guy is freaking out. All right. So slope is considered, another word for slope or a phrase for slope is rate of change. It's how much stuff is changing. This dude, he's started out here at the ground and he's going up. So how much he is vertically changing because his altitude is changing, and how far he is horizontally changing because he is making progress and going forward. If you're in an elevator, you're simply going up. You're not actually changing your horizontal distance at all unless you're walking in the elevator. I guess that'd be a little bit horizontal distance change, but the primary change is going to be your vertical change. This one has a horizontal and a vertical change in order to reach the peak of this slope. This guy over here, he's going down, so there is a vertical change there as well as a horizontal change to end up at this location. This dude over here that's snoozing, he's only making a horizontal change. He's not making any vertical change. And then the guy falling off the cliff is making a lot of vertical change and not so much a horizontal change. So we can call these slopes. Positive slope is our first one, which is why he has a positive thought, because we're going up, that's positive, and we're going forward, that's positive. If we went backward or down, either of those would be a negative. So positive slope is going up and to the right. Negative slope, he has a negative comment, I don't like skiing, and so that is going down. He is still going forward because there's still one negative. I could also, if I wanted to go backwards, I'd be going left but up. So as long as you have one negative direction, it will make it a negative slope, and you'll see that more in our graphs in a sec. This snoozing guy, he has zero slope, because he's not going up at all. He's just going forward and going for it. And then the dude falling off the cliff is called undefined slope. And we can see these on graphs. So I'm going to make quick sketches for each of these. And then I'm going to use a different color to draw the graph on them. That way it's clear. So a positive slope example looks like that. Notice this line is continuing forever in both directions, but we are going up and to the right Or if we wanted to go backwards, we could go left and down. But we have two negative directions for that because down is towards the negatives of my y values and left is to the negatives on my x values. Negative slope has only one negative, so you're either going down and to the right positive, or you're going up and then to the left, which is that one negative. Zero slope is just any horizontal line. Undefined slope is any vertical line. And examples that would match roughly the sketches that I drew here. This one could be like y equals 2x plus 1. And this could be y equals negative x. This could be y equals 3, and this could be x equals 3. So just, you're not going to understand what that means now. Totally fine. It's just so when you look back at this later, you could see examples because we're going to learn what all these different forms mean and when they're used and how we created them. We need to keep the blue open. Okay, so slope is the same thing as saying rate of change. There are a lot of phrases, there are a lot of terms, there are a lot of variables that represent slope, and you're going to see a lot more of them as you learn more things about functions and everything in math beyond this, because it all relies on slope. So just an FYI, there are multiple representations that mean slope. Okay, and one of those could also be m. M is a variable that represents slope. There's no good real reason. Some people said it's like the French word for slope, which starts with an M, but it really was made for no reason. Yay, the fun of math. Some things make sense, others are just like, let's use this letter. All right, so rise over run. The rise is going to be the change in your what? It's the change in your y's. So if you start at 0, 0 and end up at 0, 4, your y, or your vertical change, is 4. Whereas your run, like this guy who is just snoozing on it, his y's change is nothing, but he's running far. So he started at, say, 0, 0, and then he's running towards 10, 0. So his horizontal change would be 10. So your rise is your change in your y's, your run is your change in your x's. And how do we find change? If I'm buying a soda, that's $2.16, but I only have $3 bills, so I'm going to pay $3 and I'm going to get back change. What's the calculator in the computer or the clerk, what are they doing to find me my change? They're subtracting. So we find change by subtraction. So if I want the change in y's, I need to subtract 2 y's. If I need the change in x, I need to subtract 2 x's. So my slope formula will be subtracting 2 of our y's, which I can't just put y minus y because that'd be the same variable. I have to make them look different. So I'm going to have a y sub 1, sub means that subscript, minus y sub 2, all over x sub 1 minus x sub 2. You could rewrite this where it says y sub 2 minus y sub 1, x sub 2 minus x sub 1. The goal is that the pair, the ordered pair, has to be put together. So this is your formula when you're given 2 points. Well, you have an x1, comma, y1, and you have an x2, comma, y2. Notice the x and y that are in each coordinate are vertically paired with each other. They have to be aligned up, but all your y's are in the numerator and all your x's are in the denominator. Okay, we're going to do 4 examples. So we are finding slope. So our first one, second one, third one, fourth one. 3 and 4 are going to be on graphs. So if you want to prep that work now, we'll put 3 tick marks. 1, 2, 3, 1, 2. Well, 1, 2, 3, 1, 2, 1, 2, 1, 2, 1, 2, 3, 1, 2, 3. Okay, and I'll just write the coordinates. Okay, so let's do 1, 2, 3, 6, negative 1, 4, 5, negative 2. Okay. So if you want, it's really helpful if you label these. So x1, y1, x2, y2. That way you know already where you're going to take that variable, take that number, and stick it or place it into our formula. So slope equals 2 minus 6 over 1 minus 3. 2 minus 6 is negative 4. 1 minus 3 is negative 2. Two negatives divide to make a positive 2. So my slope is 2. Now, we could write this as 2 over 1. That is perfectly fine. This tells me that I'm going up 2 and I'm running right 1. Those are my directions. Slope is just telling you direction, how to get from point A to point B. What is the vertical change that you have and what is the horizontal change you have? Sometimes they're negative, sometimes they're up, down, left, or right. Sometimes it's 0. They're just going one direction. They're not going up or down. And then our second one, try this one on your own. All right, so I'm going to have 4 minus a negative 2 over negative 1 minus 5. Notice that these two negatives, when you're subtracting a negative, they're smack dab next to each other. That means you're adding a positive. So I'm going to go plus, plus. These two negatives are not next to each other, so I'm not going to change them in any way. So this will be positive 6. This will be negative 6. Wow, this is a really nice number. I did not expect it to be this nice. So you could write this as negative 1 if you wanted. You could also write it as negative 1 over positive 1. Or 1 over negative 1. So notice with the negative, you can move it into the numerator or denominator. If there's one negative, it has to be used only once. This means I go down 1, right 1. This one tells me to go up 1, left 1. But they're exactly the same pattern. So if you plotted points using these directions, you would still get the same line. Okay. Yeah, we'll do that one. All right, so I want to point, I'm going to use my pen just so, well, no, I'll use the marker and then I'll use the pen for my answer. Okay, so I'm using the coordinates 0, 1, and negative 2, 0. And then the second one I'm going to use 1, 0, 0, negative 2. All right, so you could take the points off of the graph and then use the formula. Perfectly fine. That's a great strategy. Another strategy on the graph is literally to go from one point to the next. It's nice to go left to right, but I'm actually going to go left to right on this first graph. I'm going to go right to left on the second graph just so you see an example of both. So going from one point in the left to the other point on the right, what are my directions? My directions tell me to go up 1 and I'm going right 2. So my slope is going to be 1/2 because that's going up 1, rising 1, and running 2. If I went backwards, this one would be going left 1, so left 1 is down here, and then going down 2. Well, I can actually simplify this, so my slope is a positive 2 or positive 2 over 1 if you wanted. That would work fine. Or just go bloop, bloop, and you're good. So, yay! That should be it. Okay, I wanted to go do the comprehension questions. Pause it, read it, you're good. Especially the second one because that's a really common misconception. People switch up writing a coordinate in x, y, but for slope our formula goes y's over x's. So making sure that you can keep those straight is really, really helpful. All right, now I'm done. Have a great day. Bye.